Hello everyone. I welcome all of you for the today's session that is demonstration of CAENexus. So CAENexus, it automates CA workflows, that is both FEA and CFD workflows. So it automates from start to end, that is from CAD till report generation. And in today's session, we will see how exactly the CAENexus works or how exactly CAENexus automates start to end process. So there are basically two inputs needed in this automation. So the first one is the abstract model file. So whatever you're seeing on my screen, it's an abstract model file authored by an analyst. So here on left hand side, you can see the classes. At the bottom, you can see the relation, and at the center, you can see the attribute window. So analyst will make use of classes and the relation to specify the physics with the help of attribute. So this is the first input needed for the automation. The second one is the CA ready CAD. So this is a linker mechanism. It's a small assembly, and this is a parametric CAD. This is not a dumb CAD. And along with the CAD preparation, one need to add some CAD parameters as well. For example, SCOMP and S classes. So SCOMP basically stands for simulation component, which represents your product, and S classes, it stands for simulation classes, which represents or captures your solver physics. So these are the two inputs needed for this automations. First one is the abstract model file, and second one is the CA CAD. I will talk about these two input in more detail shortly. Prior to that, maybe I will quickly show you how exactly our customers are using CAENexus to automate their start to end process with the help of some batch commands. Yes. So this is the input XML, which is published by Novus Nexus. So it's a simple text file and it has two inputs. So first one is the abstract model block, which in turn will generate the abstract model file. And the second input is your geometry details. That is which CAD part you want to analyze and the respective CAD modeler. So in this case, I'm using Catia with V5R29 as a version. So our customers, they are changing these two inputs as per their need. So once it is done, then they are using the CAENexus command prompt, and they are using the first bash command, that is cn autorun minus prep for automatic pre-processing. So prep stands for pre-processing, and with this batch command, automatic pre-processing will start and you will have your solver input tech ready in your working directory. So if I click enter here, then the pre-processing will start and it will take some time. Till then, maybe I'll give you more details about the two inputs that I've talked earlier. Yes. So as I said earlier, the first input is the abstract model file, which is authored by analyst. Now this file is created with the help of abstract model blocks from our existing library. And in this file, you can see on left hand side, these are the classes. And at the bottom, these are the relation. So what exactly the classes are? So classes basically are the entities which does not have any specific shape, but has some specific dimension. So for example, here, solid is the class which belongs to 3D dimension. So it's a volume class. So likewise, one can have any number of volume classes or maybe the surface classes or 1D or 0D classes. Also, each class will have its own child entities. That is, boundary, interface, interior, pruned, and one can use these classes and its child entities as per the need to specify the physics in the attribute. Now the relations here are basically the relation between two classes, and it will help you to get the common entities between the two classes. Maybe I will explain you the concept of the class and relation with the help of some small examples. Yes, you can see here on left hand side, this is a gray box. And if I say, or if I assign solid class to this gray box, then solid will represent this whole geometry. If I say the boundary of solid, then it will represent only the outer surfaces. Same is the case here. Let's take the example of these two cubes. So one is red one and another is the gray one. Both these cubes, they are in touch with each other. And if I assign solid class to both these cubes, and if I say the interface of solid, then it will give me the common entity between these two cubes. That is, it will give me the common surface between these two cubes. Similarly, in this third example, this is a solid part and this is a surface. And if I assign solid class here and shell class here, and if I use a relation between these two classes, then relation will highlight the common entity between these two things. And that common entity in this case is a edge. So this is a concept of class and relation. So analysts, they'll make use of these classes and relation in their abstract model file, and they'll specify the physics with the help of attribute. So here the center window is the attribute window. It has 4 tabs at the top: meshing, solution strategy, problem definition, and output. So meshing tab, it will cover all the mesh related physics. Solution strategy, it will have, like, you can specify what kind of analysis you want to do, maybe static model. So that information you can specify here. The problem definition, it will cover rest of the physics, like what is your material, what is your boundary condition, what are the contacts. So those kind of details will be here. And the output tab will cover what output you want from the analysis, as well as it will cover some attributes related to post processing. So maybe quickly I'll cover some of the attributes so that it will give you some more details here. So for example, if I see the mesh size attribute and if I open this attribute, you can see this attribute is specified on the solid class, and here in the mesh size, we are seeing that fetch the value from the CAD against the CAD parameter mesh size. So one can specify the size directly also, but if we fetch it from the CAD, then it adds more flexibility to the abstract model. Similarly, I will show you one more attribute, maybe the surface mesh type. So all of you know that mostly we prefer chord dominant mesh for the surfaces. So that is specified here. And if you see, we are specifying it on the shell 2D class. Same is the case for the attributes from solution strategy. Maybe I'll just show you one of the attribute. So here, if you see, this is the attribute of analysis type, and static analysis is specified here. So one can specify the type of analysis based on the requirement. Couple of more attributes from problem definition. So if I talk about the solid attribute, then if you see here, this attribute, what we are specifying is, we are specifying what element type we want, and we are saying that import the material name from the CAD against the CAD parameter mat name. And this attribute is specified on the solid class. So if you see all these inputs, element type and this information, all analysts, they are familiar with this information. And the only difference is we are specifying this physics on the classes. We are not specifying it on the mesh. We are not specifying it on the CAD. So this is the difference. Similarly, maybe I'll quickly cover one more attribute of, let's say, concentrated load. So here it is specified on C load phase solid. So the relation is used here and the load is specified on this relation, that is relation between C load phase and solid. And we are saying that fetch the load values from this load XML. So this is how in CAENexus we are specifying the physics either on the classes or the relation. Maybe a couple of attribute I'll talk from the output tab as well. So here all of you know that we generally request the uh, output related to displacement and the stresses. So that one can specify here through this esolve attribute. So you can specify the load step IDs and other details as per the requirement. This attribute, CN post, it's actually related to the post processing. It specifies what solver or the solver path that you want and the post processor that you want to use for generating the report. So at the moment I selected Hyperview, but we supported ANSYS Workbench as well as vCollab as a post processor. So this setting user can give here in this post processing attribute. So in nutshell, I would say that analysts will make use of classes and relation and will specify all the solver related physics with the help of attribute in this abstract model file. Also, this abstract model file will contain the attributes related to post processing or related to the report the way you want it to be generated. So this is all about the first input. Now we will see more details about the second input. But prior to that, maybe I'll quickly check what is the status of the batch command that we have started. Yes, you can see here the first batch command, that is cnautorun minus prep, is executed successfully. So with this command, you will have your solver input deck ready in the working directory. Maybe I'll quickly show you that as well. So this is the working directory and you can see this is the solver input deck, that is linker.cdv generated here. Maybe I'll quickly open this as well. So this is the ANSYS solver input deck and it has the solver related information like node details and other kind of thing. So this is the first batch command that our customer they are using. The second batch command that our customer they are using is cn autorun minus solve. Now with this command, what is happening is whatever solver input deck generated with the help of this first batch command, it is getting submitted to the solver, and once it gets completed, then you will have the result files in your working directory. Now again, it will take some time. Meanwhile, we'll see the details of second input that is needed for the automation. Yes, so as I said, the second input needed for the automation is the CAD. So this is a linker mechanism, and you can say this is created by a CAD engineer. It's not a dummy CAD, it's a parametric CAD. And as I said earlier, we need to have or we need to add some CAD parameters in this CAD. So scomp and sclasses, those are the CAD parameters that has to be added. So SCOM basically stands for simulation component and it represents your product, whereas S classes, it stands for simulation classes, which represents your solver physics. Now, if you see any simulation, it will have some maybe solid part, maybe some shell part, or maybe some parts which you're not interested for the simulation. So you'll not carry out the meshing for that part. So accordingly, you need to add the classes. For example, here the solid is added. Maybe for some parts, I will quickly show you here some body class is added because the body will represent it is a part which will not take a part in the simulation. So likewise, one need to keep on adding the simulation classes. Maybe I will tell you one more thing related to material. So this is what the mat name parameter added because every part will have some material. So here for this part, still 1430 material name is specified. Now, if you remember while talking during the abstract model file, maybe for the attribute from the problem definition tab related to solid. So I told you that in this attribute, what we are specifying is we want the solid element or the solid 187 as the element type, and we want material to be taken from the CAD, which is against the parameter name of mat name. So this attribute will take the name from here, that mat name steel 1430. So it will happen for all the parts automatically with the help of single attribute. There are other classes as well. For example, one more CAD parameter is the mesh size. So one can specify the mesh size on the CAD. As I said, one can directly specify the value in the attribute also, but if you add it here, then you'll have more flexibility and you can adjust the sizes based on your requirement, whether you want the finer mesh or the coarser one. So this is how one need to add the SComp and S classes to the CAD. Again, don't have to do this manually. We have a CSV functionality or the Excel functionality where you can import and export the tags. So you can just fill out the Excel and you can directly import those tags in your CAD model. So it will not take more than 5 minutes and it's very efficient one to do the tagging. So this is the second input that is needed for the automation. Now I will show you some manual thing what happened at the back end when I just did the prep command. But prior to that, let me first check the status of the second batch command. What has happened to that? So you can see here the second batch command, that is CAENautorun minus solve, it has executed successfully. So the solver files are there in the working directory. And the third command that our customer they're using is the CAENautorun minus post. Now, what this command will do is it will take the result file and the post processor thing, whatever we have specified in the abstract model file. Based on that, it will auto generate the report in the PDF format. So I will just start this command and then we will see how exactly the CAENexus links the abstract model file and the CAD model. Now, once your both the inputs are ready, that is the abstract model file as well as CAD, then rest all processes are automatic and you'll directly get your solver input tag. So that we have seen with the prep batch command, but I will just show you what will happen at the back end when we are using that prep command. So firstly, CAENexus, it will link the abstract model file with the CAD model. So for that, I will have to click here. So I'm going to show you the manual step, but all these things will happen at the back end with that prep batch command. So if I click here, then it will ask me for the CAD model that is to be linked with the abstract model file. So I just select this CAD model and I'll click on open. Now here, CAENexus is creating a simulation model. So it will take some time. So I will quickly show you already created simulation model. Yes. So you can see here on my screen, this is the simulation model which is created by linking abstract model file with the CAD model. So here you can see these are the classes, here these are the relations, and here these are the attributes. So if I click on solid here, then you can notice some of the parts are getting highlighted here. And the reason why these parts are getting highlighted because in the CAD model, we have assigned solid class to these CAD parts. Same is the case for the attributes. For example, here if I see this solid attribute, then whatever physics we have specified on this solid class, that is element type 187, and import the material name from the CAD, that will transfer from the classes to actual geometry. So you can see that from here, from class to the model window. So if I click here in the model tab, and if I check this solid attribute, you can see, you can find different regions here. And if I just click on one of the attribute belonging to one of the region, then you can notice that a material is fetched here from the CAD. So this is how all the physics will get transferred from classes to the actual geometries, and you can see those details in this model tab. Maybe I'll quickly show you one more attribute, that is mesh size. So here if you see, what we have specified is that fetch the value from the CAD, and this attribute was specified on the solid class. And if we check in the model tab, you can see here maybe in the mesh size, and if I just expand this thing, you can see that the mesh sizes are automatically came here. So this is how your attribute which you have specified on the classes will get transferred onto the actual geometries, because you have specified those classes in your CAD part. So this way all the physics will get transferred to the real geometries. Now after this, the second automatic step that CAENexus does is it carries out the meshing. So for that I will have to click here, but I will directly show you already created mesh. So now this mesh depends on whatever mesh attributes, that is mesh size, mesh curvature, minimum curvature. So whatever attributes you have specified, based on that, the mesh will get generated. The third automatic step is the export. So for that, we need to click on this icon, and CAENexus will export the solver input there. So these three automatic steps will happen at the back end when you are using that prep command. So this is all about this CAENexus automation. Maybe I will quickly see the status of the post command. Yes, you can see that CN post is executed successfully. It means the report must have generated in the working directory. Maybe I'll quickly go to that, and you can see this is the PDF which is generated as a report. So I'll quickly go through the report as well. So this is the auto-generated report by the CAENexus. This is the first page highlighting what CAD model is used here. Then on the next page, you have the content. So what are the contents there in this report? Then a model summary which details about which abstract model block and the CAD software you have used, the solver, analysis type. So that information is here. Some details about the material and its properties. It is mentioned here. Then the parts and their corresponding material, whatever material those parts are having, so that is mentioned in this tabular form. Simulation inputs, what are the loads used, what are the constraints used, so that information is here in this simulation input. Then you have the model views and the mesh views corresponding to your load cases. Then you have the displacement plot. Then you have your displacement plot for the another load case. Then the stress plots for both the load cases and the strain plots for both the load cases. Also, you'll have some links here, animation links. So if you want to play the animation, then you can just click on those links and you can just open it and it will then show you the animation. And the last slide will be your simulation output. So what are the displacement strain for the particular load state? So that information is given in the tabular format. So this is the standard report that is generated by CAENexus with the help of Hyperview as a post processor. So this is all about the auto-generated report. I want to also highlight one more point, that is, let's say tomorrow you're dealing with some different geometries, then in that case also you can use the same abstract model file. The reason is you will have the same classes for this new geometry as well. Maybe quickly I'll show you simulation model as well. So this is the simulation model for this coupling assembly, which is altogether different than your linker assembly. And if I click here on the solid, you can see some parts are getting highlighted here. And the respective physics through an attribute will get transferred onto these parts. Now, the reason why you can reuse the abstract model file, because we are specifying the physics on the classes and we are making sure that these classes are present in the different CAD models. So reusability of abstract model file is one of the key aspect. Also, if you see the abstract model file, it's a very small abstract model file. The size is very small and it actually captures all the knowledge from the analyst. So what should be the meshing parameters, then what should be the loading and the material details, its properties. So all those information is getting captured in this abstract model file and it is captured in a very tiny format. So size of abstract model file is very lesser than 5 MB. So this abstract model file serves the purpose of the data management. Also, you can share this abstract model file across the teams and all will get the consistent results because all are going to use the same abstract model file and there's no chance that anyone can make a mistake. So this file can be shared across the team and you will get the consistent result out of that. Also, as I've talked about the bash command, so our customers, they are running the simulation 24 by 7 because there is no any human intervention and with the help of those bash command and the production mode, you can just run your simulations 24 by 7. It increases the productivity and as per our customers' feedback, they are seeing 5 to 10 times more productivity as compared to their traditional approach. So these are some of the key aspects or the advantages of CAENexus workflow. I will quickly also cover one more point related to the web-based application. Yes, you can see here, this is a web-based application that we have developed, and here one can give the inputs like geometry and the abstract model file. And once you click on the submit, then all the processes that I've talked about will take place at the backend and the user will directly get the report out of it. So anyone can use this application and can submit the simulation and get the report out of it. So this is specific to the FEA and same is the case for the CFD as well. This is one of the CFD app where you can put your solver details here. Then you can have your geometry details here maybe some inputs like initial velocity and temperature that you can specify here. And once you submit it, then all the processes will happen at the back end and you will get the report out of it. So such kind of web-based application can be developed, and analysts as well as designers, they can start submitting the simulation. So this is all about the automation offered by CAENexus. I hope it must have given some more insight about how exactly the CAENexus works. In case if you want some more details or if you have any queries, please feel free to contact us. You can contact at support@novusnexus.com and we'll get back to you accordingly. So thanks everyone for attending this session, and I'll just say that have a good day. Bye.